a decent video. Okay. Let me make sure it's plugged in.
And
You can hear me.
All right. Chapter 4, polynomials and rational functions. When you were taking the notes on Friday, this slide right here reminds you that terms of polynomials are separated by plus and minus signs. This is the formal definition of writing a polynomial, but if it's a little bit Greek, that's okay, ignore it. It's just saying that you always put the highest exponent term in the front, and then they always should count in descending order, and any term that has no variable at all, which is called a constant, should be at the end. Leading term would be the term in the front. Degree is the highest exponent, which should be with the leading term. Exponents in descending order. Here were examples. This is a constant function because it's x to the 0 power. Leading coefficient is just the 3. This is linear. It's x to the 1st power. Leading coefficient is 2/3. That's technically not a polynomial. This is just saying, can you recognize what leading coefficient means? Quadratic, cubic, quartic. Are there any questions on this slide? Being able to identify leading term, degree, leading coefficient, and type of function. Okay, next slide was letting you know that we are dealing with polynomials, and polynomials, which is one of my favorite things, they have nice integers. There are no fractions, no decimals, no radicals, no negative exponents, none of that, which is why I like polynomials. This slide was showing you how to break down a polynomial by all of its different properties and then sketch a graph. There's a lot to take in here, but a lot of this is stuff you already know. It's just putting it all together on one page. So let's start with the quadratic. This was a quadratic. If I want to be able to see what the zeros are, I need to solve it. Zeros means solutions. Where is it crossing the x-axis? So I factored it, and I got it in factored form. Let me show how. Okay, I can do this. I have to remember that if you're watching the video, you can't see what I'm pointing to. Okay, so this is factored form right here. From the factors, I can get these zeros. Does everybody understand how I did that? And then I can write zeros as actual points. So the function in factored form, the zeros and the x-intercepts, all just kind of are in one step. You can answer all three of those parts in the process of just solving it. Awesome. You need to be ready. Get off work on it. Be ready. Y-intercept right here. Oh Lord, what did I do? The y-intercept that's right here. The way that I found that, you might want to make this note because I don't have it written up there, is if it's the y-intercept, it's where it's crossing the y-axis, which means x is 0. So you just plug 0 into the function. It's easier to plug it into the original function, not the factored form, because if you plug it into the original, notice that this goes away and this goes away, and you're left with -3, which is how you can find that just in your head like that. Like down here, what's the 0 of this? Not 0, the y-intercept. What's the y-intercept?
-12.
-12. Because this goes away, goes away, goes away, it'd be negative 12. So the y-intercept should be easy peasy, lemon squeezy. Max and min, because this is a quadratic, you can either go to your calculator and find it, but I would use that shortcut for the vertex. And then I would just ask myself, is A positive or negative? Which way is it opening? And then you know if it's a max or a min. The shortcut for the vertex is right over here. Negative B over 2A. Then to get the y value, you just, whatever you got there, you plug it back in. Right? Domain, all real numbers, because it's opening up and going out. So it's going to cover the whole x-axis. Range, you're going to have to look at the graph to get an idea of range. If it's opening up, then it's going to start somewhere and go to infinity. If it's opening down, then it's going to come from negative infinity and top off. But you use the y value of the vertex for the range. You should notice that this is the y. This is the y of the vertex. Not the y. What is that? The x. No, it's the y. Help me out. It's the y. Okay, that was quadratic. What if it's cubic? First of all, I would never give you one that does not factor by grouping. Okay? It either will already be in factored form or it will factor by grouping. That particular problem does not factor by grouping, so I just went ahead and told you what it is. The zeros come out of it, write them as coordinate points. We already talked about getting the y-intercept. The max and the mins, you're going to have to use your calculator and do second calc, okay? You can't do that in your head. So that's a calculator step. Domain, all real numbers. Range, all real numbers. Are there any questions on this slide? Yes?
What would be
Are you sure? Now I'm
I
curious.
thought
though.
this was talking about.
Oh, no. There you go.
I see that.
Yeah. Sorry. All right. Then this slide was to show you the similarities and differences, actually the difference, in polynomial functions and non-polynomial functions. I just realized Chloe's not here. I need to mark her up. So. What do you notice is different between polynomial and non-polynomial? Starts with a C. I'm looking for a word that starts with a C that describes what? Thank you. Polynomials are curves, with the exception of the constant function where it's a horizontal line. But polynomial functions are curves. This is the absolute value function right here. Notice it's a v. This is the square root function, so it's half a curve. This is a rational exponential function, which is like an absolute value, like it looks inverted. And then this is just a rational, which has two parts. Notice polynomial functions have one graph, and they're curved. There's no sharp points, and they're not disconnected. Okay? Which brings us to the word continuous. Polynomial functions are continuous, meaning you can take your pencil and trace it without picking your pencil up. This is discontinuous here and here because I would have to pick my pencil up to continue tracing it. And you might be wondering, how is this one discontinuous? It's because of the hole in the middle of the curve. because polynomial functions, y'all staying with me? Because polynomial functions are continuous, the domain, this is major right here. I'm giving you the answer to a question that will always be true, so I hope you're listening. The domain of any polynomial function is all real numbers, and it's because it's continuous. There's no holes, there's no gaps, there's no breaks. You don't have sharp, jagged pieces. Like it's continuous. So the domain question for every single one of these should be all real numbers. Negative infinity to infinity. Don't get that wrong, because then I know you didn't listen to me. This slide was introducing you to what's called the leading term test. You're already familiar with the leading term test when it comes to quadratics. If a quadratic's leading term is positive, it opens up. Yeah, I was gonna be like but y'all were like Thank you. It's what Tennessee did all weekend. Right? You know, the score is 59-3. It was not worth watching. Shut up.
They're 1-7.
If Georgia wins,
They're 12 ranked in the country.
Who?
Missouri. Is that what you started asking about? Missouri?
So you're not going to even let me finish before you just start trying
I'm
to
very upset about the rankings.
You should be. Y'all suck.
Whoa.
I'm just kidding.
Hey,
I'm kidding.
What's our
you
win?
better have this same level of trash talk next week when you play Tennessee. When you
Missouri.
play Georgia.
We're
You
talking
play
Saturday.
Missouri this Saturday. You play Georgia
in
next
2
Saturday.
weeks.
Wait a minute. Krispy Kreme.
I think your mother is someone at the door. Oh no.
Yo, she's got Krispy Kreme on it.
Hey, what's our win?
I'm highly interested.
Are we back to back?
As we were saying that you already... Oh, I just got a text that she's here. As we were saying that you already know how to do the leading term test with quadratics. Positive leading coefficient, it opens up. Negative, it opens down. Okay. The same rule applies with polynomials. So the only thing you have to really learn is the odd degree polynomials. That's the only one you have to learn. And the reason for that is because even degree polynomials, whether it's 2, 4, 6, 8, 10, 12, you see the pattern, does not matter. They have the same end behavior. They either both go up or they both go down. Now the difference is, notice the curves in between, right? There's curves in between. That's the difference between a second degree, fourth degree, 6th degree, 8th degree, 10th degree, yada, 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 yada. And actually, to kind of give you a preview of what's to come eventually, we're not doing it right now, but just, it's kind of neat. This is what I like about polynomials, because this stuff works every time. If it's an even degree, I know it's either both up or both down. Then I look at the degree itself. If it's, say, to the 12th power, then I know there's going to be a bunch of curves in the middle, right? How many possible maximum curves could it have, do you know? If it's to the 12th power, it's 11. It's always n minus 1. Think about a quadratic. How many curves does a quadratic have? 1. So how many curves can a 12th degree polynomial possibly have? 11, or 10, or 9, or 8, or 7. You see, what about a 16 degree? It can have 15 curves in the middle.
Is that how many zeros it has?
Not, it can have up to the number of zeros that the degree is. So it can have 16 zeros, 15 curves in the middle of the graph. Odd degree. Opposite. Please relate the word odd with opposite. Opposite ends. Okay? I feel like I'm a cheerleader now. I would be a terrible one. But opposite ends, instead of going in the same direction. You know where this is going. What's the movie? Saturday Night Fever. Right arm up, left arm down. Memorize that this is when it's positive. Because if you'll memorize this is positive, how do I get negative? You just flip it. And you'll get it right every time, okay? Don't look down on being goofy for a second, if it helps you remember it. Notice that the range of every odd degree function is all real numbers. Why? And behavior is covering the entire y-axis. So it's all real numbers. So what type of polynomial should no one get domain or range wrong for? Odd. Because the domain's what? All real numbers. And the range is what?
All real numbers.
If you get the domain and range wrong on an odd degree polynomial, I know you're not listening to me. So write it down. Put it somewhere. Odd degree polynomials. Domain and range. All real numbers. Every time. Every day. All day. The only one that you have to actually stop, read, look, check is the even degree. And still, that's just the range. Because what's the domain? All real numbers. This is just a chart to give you, this just sums up what you already know. I know when you might look at it, you might think, I have no clue what I'm reading. They're saying, hey, if it's an even degree and it has a positive leading term, leading coefficient, it's going to open up. It's going to have some stuff going on in the middle, but we're not going to get to that. They're just saying it's going to open up. If it's negative, it's going to open down. If it's odd, positive, it's Saturday Night Fever, right? And if it's odd, negative, it's going to flip. This was practice. Notice the only thing you needed to look at was the highlighted leading term portion. None of the other polynomial terms mattered at all. In fact, that's not even a polynomial right there with it being a fraction, but it doesn't matter because all I needed to look at was the leading term. Did anyone have any questions on this slide? Now do y'all see why I left this for y'all? Because it's not bad until you got to the algebra part, which we're fixing to go over. This slide right here is showing you 3 different ways to work with a single quadratic. This was the quadratic you worked with on this entire slide in the middle. They were showing you how to get it in factored form, how to set them equal to 0, how to solve, how to state that those are the solutions. Then they showed you the graph to show you the connection between the zeros are the solutions where the curve is crossing the x-axis. This example right here is saying, hey, here's a polynomial. Determine if 2 and negative 5 is a 0. They're saying determine if 2 and negative 5 are solutions. To check if it's a solution, you just plug it in and it has to equal 0. If it does not equal 0, it's not a 0. So use the word to remind you of what to do there. I plugged in 2 and I got negative 7, which means no, it's not a 0. I plugged in negative 5 and I got 0, so yes. If I was to graph this crap, it would cross the x-axis at negative 5, is what that means. It's a solution. If I was to solve that crap, I would come to negative 5 as one of them, not all of them. This was just saying, hey, check this one. Any questions on this slide? This was more practice. Find the zeros. This was already in factored form. So you just pull each factor and set it equal to 0 and solve. I don't know why I have a big bar underneath that.
You were showing it in the video about how that one was factored
Oh, okay.
and the other one was condensed.
Okay, gotcha. Because of this right there. There you go. Alright, so this says x minus 2 cubed. In expanded form, it would look like that. The zeros here will only come from the expressions with x. So I remember somebody asked me one time, what about the 5? The 5 has no x, so it's mute. Like, ignore it. It's a GCF, but in terms of zeros, it doesn't matter. Now, what if it was 5x? It does matter. You'd set it equal to 0, you divide by 5, and you would actually get the number 0, right? So be careful there. If it has an x, it gets set equal to 0 and solved. If it does not have an x, you can ignore it. It's just a GCF. Now, this repeated thing. Repeated means exactly what it sounds like. It's a factor raised to a power other than 1, so a higher power, which means it's repeated multiple times. When you go to graph your polynomial, repeated zeros change the activity of the curve. Instead of just a normal kind of an S motion, when it has a repeated 0, it's going to do one of two things. These are both, okay, that one's odd. All right, I'll do it right here. It's going to do one of two things. If it's repeated an even number of times, it means that, and I'm not graphing this whole thing, I'm just going to show you as if we were zoomed in right on the curve. You with me? I'm not graphing the whole thing. I can't even talk. All right. If it's an even repeated 0, it means the graph is coming to the x-axis and bouncing off. A mini quadratic, like a mini little quadratic. Or it can come to the x-axis and bounce off, like that. If it's an odd repeated 0, you probably know where this is going now. It's like a little mini Saturday Night Live. And it actually lays across it and then goes over. Or it can come down, lay across it, and go down. Instead of this nice, like this. You know what I mean? That's the typical polynomial. You throw in some repeated values, now it's going to either bounce off the x-axis or it's going to come to it, lay across it, and go over to the other side. The way I remember it is I think of a mini quadratic and a mini Saturday Night Live. And that's how I keep up with it. So it's going to bounce at 1, even, mini quadratic. It's going to bounce at -2, mini quadratic. Okay? Yes?
What, is it repeated like 5 times?
Yeah, that'd be odd. So that'd be a mini. Oh, no, in terms of. No. Yeah, it's the same. I think it just goes with how long it stretches out. But we're not getting into that. I'm just looking for you to be able to say if it either bounces or crosses. Which brings us here. Perfect timing. You were supposed to find the zeros. This has 4 terms. You should have factored it by grouping. Did you get that? Remember we talked about how these have to do what? These have to match. They have to match, or you've done something wrong. Either your GCF was not right, or looking up here, maybe you factored wrong. Now that's my GCF. So visualize me picking up the green and pulling it to the front one time as a GCF, and I'd be left with x squared minus 9, right? I'm finding the zeros. Now you could go straight to zero product property here, or some of you might look at this and say, hey, what's that? That's a difference of squares. I heard someone say it. Now, if you don't see that, that's okay, because if you set it equal to 0, x squared minus 9 equals 0, you're still going to get positive negative 3. So you don't have to I'm going to draw a strike through it because it's not necessary. It's great if you see it, but it's not a must-have because I can go straight from this to my zeros. This would be 2, add 9, square root 9. What's the square root of 9?
3.
When I'm solving. Positive negative 3, right? So the zeros there are 2, 3, and negative 3. The next one says find the zeros, and it gives us a quartic polynomial. We're going to use U substitution. You with me? You watching film?
No.
We're going to use U substitution. Remember that x to the 4th can be written like that. Right? So that would be u squared plus 4u minus 45. Where did the u come from? I let u equal x squared. And then I substituted u in for x squared. Now I can solve this by factoring. What are the factors of negative 45 to add up to 4?
Positive 9 and negative 5.
What?
Positive 9 and negative 5.
Yep. You have it in factored form. Now you set them equal to 0 and solve, or you could just pull the zeros straight from this. Here u is negative 9. Here u is 5. A couple of people, I am grading your exams from last week. I got like 7 people maybe graded before I left. I was not taking it with me on vacation because the only laptop that I can grade it on is the work one, and then that thing is bulky. And I was trying not to overpack. Yeah. My suitcase weighed 46 pounds when I left. And then they gave me a whole gift bag and I bought stuff and I was like, all right, I'm going to have to be strategic. It was like a Jenga game coming home. And it weighed 48.4 pounds and I threw something else in it and I was at 49.6 checked without having to pay $50. So anyways, I don't know why I said that. So back to this. I didn't grade your test over the weekend. I am grading them now. I'm back on it. I'm back in work mode.
I'm glad you
Thank you. I would love to be back there, but I did miss y'all to an extent.
How long were you gone?
Thursday to Sunday. Yeah. Flew right in for Riles' birthday dinner. I was not missing it. I gotta tell y'all about my Uber ride though, but I'll do that later.
Uh-oh.
Woo!
Right now.
Woo!
Oh.
Woo! Huh? No. No, I just know at one point something rolled and hit my foot and I was like, just get me there. I'm not looking. I don't know what's on my foot. I'm like holding my feet up the rest of the ride. This right here, what I was saying, I remember now where this was going. I just went off on a tangent. I remember grading, I think, 3 tests where people were so close to the right answer, but they forgot that once you have it in factored form, you have to actually set it equal to 0 and solve. So there's a sign change. You know what I mean? I saw 3 people go from the factored form and say right here, u is 9 and negative 5. No, they just forgot that last step. So I went in and I'm pretty sure I gave 0.9. The computer gave 0. And I'm like, wait a minute. I looked at your work and I saw you were all right here. You just forgot, next step. So I gave 90% out of the 100% for that value, for that point. Okay. In this case, we're not done. Because we weren't solving for u. We were solving for what? X squared. So you got to come back and do this. Now square root. I saw this on a couple of people. They forgot that when it's negative, what should be
Odd.
yeah. Or some people forgot the plus minus. Now this one's ugly right here. So you just write that it's positive negative square root of 5.
You question? Is there a you question with that?
The last one? I feel like this was a chapter ago.
You was last chapter.
I don't. Was it the last chapter or the chapter before?
Is there one on the chapter before, or the chapter 3? Because there was it as you.
Sorry. I don't remember if it was the last chapter or the chapter before, but I know that it's in our notes. Anything in your notes or homework is fair game on tests.
That was very exciting.
Just keep your AirPod out and log in. Yeah. Any questions on this slide? Anybody? Why did I get 4 answers? Keep going. There you go. The power, the degree, is setting the tone for the potential number of answers. So keep that in mind. If it's a 4th degree polynomial and you only came down to 2 answers, maybe look and see if you forgot to write positive, negative, positive, negative. Because there's up to 4 possible answers.
Are you able to just use x before x squared for the whole question? You follow that way?
No. There's no method for solving quartic polynomials other than calculator or u substitution if it works out nice.
Calculator.
Now you can go to the calculator and you could graph it and you can solve by doing the zeros on the calculator. But the problem is, Brody, it's not going to give you 3i or square root 5. It's going to give you the decimal for square root 5 and it won't mention 3i at all. So there is a downfall to that. Yeah, okay. Look at this one right here. This one, I was hoping that if you would try it right now, you are solving this by using the calculator. All of the zeros will be expressed on it, which means you're using the second calc feature. It would help if you sketched a picture of the graph. Sketch a picture.
Sure.
Okay, so
Y'all are so toxic for no
back
reason.
to this problem. You were supposed to graph it, then you were supposed to find the zeros by using the second calc feature.
Eliminate him.
And it said to go to the nearest 1,000. Are there any questions on this slide?
No.
When you're doing these problems, I would suggest sketching a picture of the graph and then making note of what you found along the way so you don't lose track of which zero you're trying to solve for. Okay? I always sketch a picture of the graph, and when I say sketch, like if this were me doing the homework, I would go to my paper and I would just do that on my paper, and then I would point arrows to what I need to find, and then I'd go to my calculator and do second calc. Okay? I would suggest that. Okay.
Womp womp.
Oh, nope. Yeah. Let me know. Oh, wait.
Pierce.
I did.
get this for that.
No,
Come out with
this
your hands
number
up.
of Dolls. So,
Like a homeless man.
Homeless man in a honey bun?
You ever put a honey bun in a microwave?
For 10 minutes?
And throw it at a homeless person?
As it's almost turned into molten lava.
Is it-
I'm gonna
here,
microwave
close
myself
up.
and give the homeless person a
Does it
hug.
say in thousands? In
What?
thousands. So to the
Me after
nearest
microwaving myself.
thousands. They thought it said thousand.
360 head.
That means
360
decimal.
let's go. Honey bun?
So 33,555 rounds to 1,000.
Maybe
When we read that, I
Wow.
thought it was decimals.
My fire.
Desire.
Okay. Shh. Still recording. Back to this. Look right here. Please look right here. Hello. Ibuprofen in the bloodstream is represented
That sounds
by
familiar.
this function. You don't have to understand where these numbers come from. You just have to understand what the letters stand for. M is saying how much medicine is in your system.
Too much.
Math. We're talking about ibuprofen here, people. M is saying how much medicine is in your system. T
Work on
is
it.
saying how much time has passed since you took the medicine. This is why
I'll be
medicines say,
slurping on
take one every 4 hours. Do not exceed more than 24 grams a day or something like that.
Learned that one the hard way.
After my C-section, I was on 800 milligrams of ibuprofen.
So was
So
Michael Jackson.
Ibuprofen. He like
they gave me some other stuff too, but I was really nervous about taking it, which I
Michael
did
Jackson
for the
followed
first.
Oxy.
these guidelines.
I don't remember.
Oxy
It's
and
been-
Zane.
But
Take
I mean, that's an intense surgery. When you first take the medicine, how many milligrams go in your bloodstream immediately?
a lot.
400 milligrams. Why don't you let people give you the medicine you need to take? Please don't try to take it on your own. I don't think you can read the
You tell me
dosage
that.
chart right.
I just pop the capsule and line it up.
Alright, find the number of milligrams in the bloodstream at 0, half an hour, 1 hour, 1.5 hours, and so on, all the way up to 6 hours. There was a lot to find here, and the fastest way to do it would be to use what feature on your calculator?
Table.
Table. You will need to change your table to show you the half marks. I can show you how to do that. You would go to table set. So you would type the function into y equals, then hit second table set. It'll say TBL SET. Stand by, mine's pulling up. All right.
Table set.
Can someone read the function to me?
34x squared.
I knew it. Somebody else.
I'm trying to find it. I'm trying to find it.
I've had enough of this.
It's this one.
You ready? You ready?
It's this one.
You ready?
It's not because you're male.
0.5 x to the fourth
T to the fourth, by the way.
plus 3.45 t to the third minus 96.65 t squared plus 347.7 t.
Anything else?
That's it.
Okay. You're going to type it in, and you're going to go to second table set. You're going to tell the calculator, hey, start at 0, and then this triangle means change in, which means how do you want me to count? You want me to count by ones? What? We want it to count by 0.5 so we can see those half marks. And then you can leave this on auto. Auto means it's going to just generate the whole running list instead of you having to type it in. To get to it, once you hit enter, you're going to hit second table. And then now I can see all the answers for this question. And they want you to copy from 0 up to 6 down. And the reason for it, I wish I could stretch this window down, but I can't. They want you to see that as you take the medicine, you know, what happens over time. Well, when you first take the medicine, it's not in your bloodstream just yet. So yes, you did just consume 400 milligrams of medicine, but it's got to absorb into your system. So you'll notice that it starts out at 0, then it goes up 150, 255, 318, 344. It's somewhere in between here. It's capping off, right? And then it starts to dissipate as it's going out of your blood system. Which is why they say to take it again in so many hours, because now there's no medicine in your system. Which is also why if you have bacteria infections, like sinus infection, or like bronchitis, if it's a bacteria infection, what is the rule with antibiotics? Do you know? I'm getting all science on you here.
Take as many as possible.
No. No,
Yes.
actually you don't want to take too many antibiotics. You'll create an anti-immune response to antibiotics. Anyways, if you've ever heard someone say, I'm on antibiotics, it's okay, they're saying that they've had 24 hours of antibiotics to fight a bacteria infection. And so that's what they mean by no longer contagious, because the antibiotics has been in their bloodstream for 24 full hours and fought bacteria off. So you're going to copy those values down. Now it says find the domain and the relative maximum where it occurs. You would find the maximum by going to the graph. We would have to go to the graph because I can't tell the max from right here because I'm only hitting whole numbers and half numbers. What if the max is at 1 3/4 or something? So hit second graph, not second, sorry, just hit graph. I can't see anything there, so I'm going to change the window. I'm going to try zoom fit. I can see a little bit more there, right? Was it to the 4th?
Yes.
Okay, I'm going to zoom out. I still can't see. There it is. All right, and it's asking for the relative maximum, meaning where's the max relative to just a certain area on the graph. It's not the absolute max because it's opening up. So looking at my picture, am I interested in anything over here? No, because that's what in terms of time. What's that? What type of time? Yeah, this is all negative over here. You can't have negative time. So this is a moo point. It's like a cow's opinion. It doesn't matter, it's moo. Where would the relative max be? Well, it looks like right here it's coming up, coming down, and then going back up, right? So I might want to zoom in on that area. Hit zoom. Oh, I'm on. Hit zoom in. It's going to curse. It's going to curse. The cursor's going to flash. I'm about to. You're about to run into something. Just a heads up.
I'm about to.
Now I can see there's a little bit of what's like a, I don't even know if I'd call that a max, but it, you know, you see where it's kind of like a little roller coaster going up. All right, I'm going to zoom in more, or I can leave it right there. And I'm going to tell the calculator, find me the value of that max. So number 4, it's going to say, okay, give me a left bound. There's a left bound. Give me a right bound.
Why can't we just like take the technology from the calculator and just implant it in our minds?
Well, because that's not the way you were designed. All right. So at 2 point, you would need 0.14. Find 0.14% of 60 minutes. So 60 times 0.14. times 0.14.
The angles of someone's going now.
So a little after 2 hours, the 400 milligrams will be at max amount 345 in your system. Are you talking to me?
I was thinking about how to put them on my get home.
This right here is talking about the correlation coefficient. This has to do with scatter plots. So, did I? Yeah, I'm sitting here thinking to myself, I don't remember that being part of the standards. But this is
We know scatter plots.
it's a good to know.
Scan back.
So it's the least squares regression line. Line of best fit. Do y'all remember that? You put
Sure.
the scatter plot in the
Line of best
Just
fit.
watch me go through it. You can do it if you want. There's not a lot of numbers up here. This is a good activity for trying to maybe predict the value of something that is, in the future. So you would go to your plots, turn the plot on. So now the plot's on. Now I've got to enter the data. Well, this is a statistics topic, so go to the stat button. And it's going to say edit, calc, or what test do you want to run. Edit means put it in the calculator. Calc means calculate the measures of spread. And test goes along with higher level statistics. I'm going to enter it in the calculator. I was going to say it's already there, but it's not. So at 0 years, 2, 3, 5, 7, 9. Okay. Somebody's going to have to read this to me because it goes off the screen. I got 492.7.
Who's got it?
522.0. 539.0.
550.1.
What? Is that my character?
Alright, I have the data in there. Now I want to see the graph. So I'm going to hit zoom since I'm doing stat stuff.
Zoom stat.
Zoom stat. There's my plot.
What?
Now I want to get a least squares.
She placed in Maggie Love for dismissal.
She's on her way.
Thank you.
Now I want to get a line of best fit. The line of best fit, you don't have to, and again, like I was saying, I'm just showing y'all this because I think it's interesting. So if it doesn't interest you, you don't have to pay attention. But we're going to tell it to run a test. We're going to do the linear regression in terms of mx plus v. I'm going to tell it, yep, I put it in L1 and L2. I'm actually going to tell it to also store it. Y'all, this should look familiar, right? Do y'all remember chapter 2? I think it was, and then it was never on the test because I took it off.
Sure.
There it is. So the line of best fit, and if you look right here, you see this R value is 0.3. R is the correlation coefficient. R means how close the line of best fit actually fits the data. You should know that R runs between -1 to 1. This is what's really cool about statistics. The closer it is to -1, that means it has a negative, strong positive association. Strong positive. That's confusing. The closest it is to -1, that means that basically you could draw a line right through the data and it's going to have a negative slope. The closer it is to +1, you can draw a line like right through the data and it's going to have a positive slope. What do you think 0 means?
No slope.
Yeah, it's all over the place. Scattered, covered, and smothered. And the line's just like shooting as best as it can through there, but like there's stuff everywhere. Notice we're at 0.36, so 0.4. So we're about like right here. So this would be a weak positive association. Now watch the graph. Nope. It's going to be really dramatic and it didn't work.
Whoa.
It hit 1 point.
What the heck?
Why is this not?
It hits 1 point, but you could use it as a predictor. It would probably not be a very reliable predictor because it only goes through 1 point, and R was 0.4. But it has to do, this is the really neat thing behind it, it has to do with the space of these points to that line. And they're trying to find the sweet spot so that all of those spaces are minimized as much as possible. Line of best fit, least squares regression. Line. All right, you've got a very small brain break, and then we are doing one problem in 4-2.
Bathroom break.
You better not be doing that blue right there, that boy.
I want to bathroom.